Hey, I am Priyanshu and I got my ML project on SUSY dataset. So the first eight features are kinematic properties measured by the particle detectors in the accelerator. The last 10 features are function of the first eight features. These are high level features derived by physicists to help discriminate between the two classes. Okay. Then I just connect my Google Colab with my Google Drive, and then I just import that Google sushi.csv file from my Google Drive, which I already uploaded on my Google Drive. Okay, then here is my data frame look like, you can see that, and then I find out the shape. So I got like 5 million data set and 19 features. So so then I describe it more and put the histograph to get more insight from it. So the most of the data is between 0 and 1 and count, mean, standard, variation, minimum. Okay. So and then after that I also want to get more insight from it, the data, for like particular features. So I get like, you can see, 3, 6 and 8 feature are more likely same and evenly same. So and evenly distributed along their range, that is between 1.5 to 1.5. So so then I box plot to identify outliers of feature 3, 6, 8 and 14. Why 14? Because you can see here, like in feature 14 there is a sudden spike on 0. You can see this. So to get more detail from it, so here is outliers, but in feature 3, 6, 8 there is no outlier. And then I find out the more correlated correlation function, which have more correlation. So uh, I found out 7, 12, 1, 9, 16, 18, 11, 5, 4 and 13 have the more correlation coefficient more than zero point 0.1. Okay. Then I applied supervised machine learning techniques. Then first I prepare the data set like x and y. Then uh, I only used 1 million data set, because if I use a 5 million data set to train my I mean to train my model and to predict it, so it will took much time to get executed if I use 5 million data set. Okay. So then I used in this particular on dataset I used random forest classifier. Okay. Then I logistic regression, then I used naive bias, and then I knn classifier. Okay, knaive classifier, and svc from, like, svc uh, is like a support vector classifier from svm. Okay. So I just train that model, and what I get is more important for us. So SVC, support vector classifier, gives us more accuracy. Like you can see, SVC is giving us 0.7973. It means 79% percentage, and it is more RFC is random forest classifier is 79155, which is more close to 7973, but more is SVC. So we can say SVC is the best classifier for this dataset. And what I did here, um, it is a time, how much time that particular classifier took to get execute. So SVC took much more time to get execute, and then RFC, then KNN, then LR, and then